give just a very brief presentation about the concept, hopefully 5 to 10 minutes, and then I'm going to go through an example, through a demo, basically, right? So basically, CCAFS Analogues was created, or this Analogues package was created around 10 years ago when CCAFS just started. And the reason it was created is because because as climate changes into the future, we have places are projected to experience novel climates. What that means is that for some particular places, it might turn out that some other place geographically, perhaps relatively distant, is going to be more similar to your current climate, to your future climate than yourself, right? And there's a number of papers that have looked at climate similarities in current and future climates and have sort of quantified this explicitly. One of the more prominent examples is this Williams et al. 2007 paper in PNAS, which estimates that by 2050s, I think, by the end of the century, there's projected to be 30%, around 30% of novel climates that have never been found. So as this climate happens, then the question is, can we use climate analogues to identify places or climates where a particular technology is known to work well, and use that evidence to then target those specific technologies to our geography or to our site of interest, right? So we launched this Analogues tool in 2011, I think, this December 2011 in the COP in Copenhagen. And basically, the principle of analogues is fairly simple. If you have two variables here represented as V1 and V2 in the X and Y axis, then you can calculate the distance between two sites, site 1 and site 2. You can calculate the distance for those two using those two variables, right? And you can use different measures of distance. In this particular case, we use the Euclidean distance, but there's also, of course, the Mahalanobis distance, which is a more complete measure of distance. And so this is the principle. The difference between this diagram and what we actually do is that we take into account not only two variables, but we take the temporal distribution of those variables. So we look at the seasonality in temperature and precipitation, and there's also options to look at a number of other variables, all of the bioclim set from WellClim. And so with climate analogues, we can try to explain differences in crop performance by using climatic dissimilarity or climatic similarity. We can, even if we have relatively limited amount of evidence, we can try to develop extrapolation domains to target specific practices or technologies, or even certain types of crops. CCAFS used it in 2012 and 2013 for a project called Farms of the Future, which was intended to promote farmer exchanges of knowledge and technologies. So in that project, the Analogues tool was used to identify villages that were similar to the future of a particular village, and then farmers would go there and visit and then see how the systems look like and how the livelihoods of those other farmers looks like. And then finally, we have an interesting case a few years ago with biodiversity, where under the International Treaty for Plant Genetic Resources with FAO, there was an analysis to identify opportunities for genetic resources exchange. And currently, with the GeneBanks platform, we have an activity where we are using the concept of climate analogues to identify subsets of accessions that might be suitable for specific characteristics or for specific locations, right? So when you think about analogues, there's three sort of possible analogues that you can think about, right? You can think about, okay, my site is projected to experience a different climate in the future. So I want to understand what sites currently have climates which are similar to my site's future, right? And in that sense, learn from these sites in the current climate to see what you might apply into the future of your site. This is what we call sort of the backward analysis. That you can do the contrary, and you can select your current climate, the current climate of your site, and then see, okay, which places in the future are projected to look like my site looks today. And that is helpful in the case you have tested a number of technologies or particular technology in your site, and then you want to find areas for extrapolation of that technology. Again, this is all under the assumption that climate is one of the main drivers of crop system and technology performance. And then finally, you can also look at current to current. So you take the current climate of your site and the current climate of many other sites in the world, and then you try to identify which ones are similar. And in this case, you can look at sort of technology transfer from those other sites to your site, or from your site to those other sites for the current conditions, right? So one particularity of analogues, and why it is sort of an interesting implementation, what we've done in this R package, is that we try to account for seasonal differences. So, and we account for that for either temperature or precipitation the user can choose. And basically, this accounting of seasonal differences means that if you have exactly the same seasonal pattern, but with a rotation, so you take, for example, a place in the northern hemisphere where temperatures are, where the winter is in the December, January, February season, and a place all the way to the south in the Patagonia where you have the winter in the June, July, August. But then the pattern, the values are actually very similar, but the patterns are inverted. What we actually do in the package is that we rotate one of the patterns to actually search for the maximum match possible, right? And so there's a couple of examples that I wanted to bring. The main example, I guess, is this. We did an analysis a couple of years ago with the CCAFS Climate Smart Villages. What we asked is, what is the representativeness of all of these sets of sites that CCAFS has defined as Climate Smart Villages? So what we did is calculated the similarity for each of these sites compared to everywhere else in the world, and then we took the 20 or so sites and calculated the maximum similarity basically across the whole set of sites, and that gives us basically the maximum extent of representation of these sites. So the findings were very interesting. Basically, you can see in this map the more reddish areas are areas where the representation of this network of sites is actually quite good. So you can see that all the way in the Sahel and also in South Asia and Southeast Asia. But when you look at East Africa and in Latin America, because there tends to be quite a lot more variability because of topography, you have less representation. Maybe also the sites were not selected to maximize this representation either. So maybe some improvements in the selection sites could be done. But anyway, it's an interesting analysis that sort of shows how useful these sites are on a global scale. Another example is, as I said, with biodiversity and FAO, we did a simple analysis to try to identify potential for genetic resources. So take Guatemala, genetic resources collected in Guatemala, where could they also be used, right? And so you can see these three circles: Morocco, Venezuela, and the DRC and Zambia, where some of these genetic resources could also be useful for climate adaptation. And that's it. As to the concepts, if there are any questions, I'll be very happy to address them now. And if there are no questions, or after the questions, then we move on to the practical example.
Okay, thanks, Julian. If there is any question, you can type them on the chatting window. Your microphones are all muted by default, but yeah, you can type in your questions if you want to ask anything to Julian at this point.
Yeah, there's a question here in the room.
No, good.
Yeah. So temperature is quite related to elevation. You could use elevation as well to calculate the similarity, but you have to use it separate to the monthly temperature and precipitation. Yeah, so this is using WorkClaim, and yeah, so the question was, sorry for those of you that are not so close to the microphone. Sorry, that didn't hear the question. The question was about the use of elevation as a variable to calculate similar climate similarity. And my answer is it can be done. It has to be done separate to the monthly data. And then the second question was whether this is using WorkClaim data. And the answer is yes, it uses WorkClaim data for the historical climate, and then it uses the CIMIC 5 CCAFS climate high resolution bias corrected data for the future scenarios. There was a question by Steve as well.
Yeah, so thanks. The question that I had is with regard to this rotation, since one of the things we're seeing is seasonal advancement, and that's functionally a rotation. How do we know when when what we're seeing is a north-south kind of rotation question versus a fundamental question of
So the calculation will rotate the climate to find the optimum match, whatever that may come from, whether it's coming from an advancement or delay of the rains, for example, or whether it's coming from just pure seasonal differences between north and south hemisphere. So it's a Fourier transform, what it does, and then it looks for the angle of rotation, and that's independent of where the yeah. But that being said, if you wanted to prevent rotation or to isolate these two types of rotations, say because of seasonality or because of climate change, then that's not possible at the moment. You can completely just not rotate, which is
So you're using monthly data on this?
Yeah.
This is using the mean values?
The mean values of temperature and the total values of precipitation.
Using other moments, so for instance, using a data set like the ERA 5 data set, where you have the daily data, this information at a daily level, and then calculating not just the mean temperatures, but calculating the standard deviation, kurtosis, and skewness, which basically gives you a much richer data in terms of the distribution of your variables.
Yeah, so this is possible. So the question from Gideon was if there's other types of monthly indicators that can be used. So the standard deviation or the skewness or other kinds of things that can be calculated out of daily data on a monthly scale. The answer is yes. So far, lots of the examples that we have use the WorkClaim data. I see I mean, of course, it's a matter of calculating those indicators and then running the analysis with those indicators. But there is no ready-to-go sort of average monthly variability, for example, that we made available at this point, right? But again, as I say, you will see in the demo that what you provide is essentially a raster stack of 12 layers for temperature and of 12 layers for precipitation, and you could change those as however you want. You can use temperature mean and temperature variability, for example, right? Yeah. There's a question here by Khaled. Which variables are used to calculate similarity matrix rather than monthly precipitation and temperature? So as this is related to Gideon's question, so the demo that I'll give uses the monthly temperature and precipitation. However, you can, as you will see, the data that is provided in the function is a raster stack, so you can change that however you want. Is it possible to compare? There's another question by Abel. Is it possible to compare a set of x-y coordinate pairs instead of just one pair? At the moment, the way the package is implemented, you choose one site and then it calculates similarity for an entire grid of target locations. What I do is that once this similarity for a grid of target locations is calculated, then I extract the similarity value corresponding to my location or other locations of interest. So this is effectively what you've just asked. Any other questions? How does Kai? How does Analogues compare in terms of performance with other models like Maxent? We haven't done any comparisons in this sense. It would be an interesting thing to do. Where we see the value, however, is not so much in using it instead of Maxent, but using it as a complement to Maxent or to these kinds of species distribution models. So what happens with SDMs like Maxent, with models like Maxent, is that you need a number of observations, right? And then you can develop a robust prediction of suitability if you have a good number of observations which are not significantly geographically biased, or if you control for bias and whatever. But if you have very limited number of observations, say you have 2, 3, 1, only very few, then it's very hard to run a model like Maxent. And this is when just looking at climatic distances, climatic similarity becomes useful. And this is actually what we're thinking with the ERA team at ICRAF, that they are working on species distribution models to look at the suitability of different agricultural practices based on this massive compendium of data of practices that they have. But then there's many practices that have very little evidence, especially for less research crops. And this is when a method like Climate Analogues becomes useful. You can still get a rough representation of what a recommendation domain might be like without having the amount of evidence that you need for a species distribution model. Yeah. All right. Okay, Tunrayo is asking, can one include soil data, for instance, ISRIC layers? Yes, you can. There's one small tweak that would be needed, but yes, that's possible.
So it's based on...
No, it's based on the Euclidean distance. So essentially what it does, it calculates the Euclidean distance and then it uses a factor to normalize the scale between 0 and 1. All right. So I'll move on to the example. I'll try to run the example on the Jupyter lab that we just learned in the morning. So the first thing I wanted to show is the GitHub repository. So here you can clone or download this repository. It's in GitHub. It's public. I'm gonna paste the address on the chat, so you guys can just click. And you can. This is directly all the package files. Basically, you can see here the README file, the Markdown file for the README, and it provides a very simple instruction on how to install it. Because it's not available on CRAN, then you need to have these library dev tools, which I think requires you having our dev tools, right? So I hope you guys have that. If not, you can, yeah, while I'm talking right now, you can just go to the R website and try to download it. Otherwise, installing DevTools is going to complain. Anyway, you can install directly from GitHub just following these two commands. And there's a couple of examples here. Right? There's one example here, right? So I want to draw your attention to this line here, data clim stack. This is just the example data that we provide with the package. So this is not the data that you should be using to run your analysis. This is just for the sake of the examples, right? The actual data you will need to download from WorldClaim or from the CIMIP 5 CCAFS climate data set, data portals. So there's essentially two functions. Once you load the package, which you load by library analogues, then there's essentially two functions. One is this create parameters. And this function has a number of arguments, as you can see here. The X and Y are the location that you're interested in. The vars is basically a vector with the variables that you're interested in. Weights are the weights corresponding to these variables. So in this case, this particular example is giving equal weight to precipitation and temperature, but you can choose to have different weightings. And divisions is the number of steps. So because we're talking about monthly data, in this case is 12. But you can see that because this is an argument, then you can modify it. So if you had soil data, you wouldn't have 12 divisions, you would have only one, right? For each of the variables that you are interested in. Then growing season, you can specify the growing season that you're interested for your particular site. So let's say for this site, I'm interested between February and June. So I can just type 2 to 6 here. And the rotation is what I said before about taking account of the seasonality. Threshold, in case you want to threshold your results. If you only want to see an output that shows analogues above a particular level of similarity, then you specify this to be below 1. In this case, it's there as 1. Environmental data reference is essentially the environmental data for the reference period, whether it's the current or the future, that's for the reference period. So this is when you have to think about what's the type of analysis that you want to do. Do you want the search range to be the future climate? Do you want the search range to be the current climate? And then that defines the reference and the target. And similar here, env data target, which in this case is exactly the same because this example is comparing current to current climate. The output directory here, it's called output file. And then file name. And then if you want to write the output. So you can choose to write it or not to write it. It's up to you. In either case, it's going to give you the next function is going to give you an object, a raster object. So after you run this create parameters function, so this function is basically just going to create the parameters. It's not going to run the analogs yet. And then we have a second function, which is this calc similarity. And this function is, it just has one parameter, which is this object. This object params, you have to, the object which is output from create parameters, you have to put there. And then you just run it, and then it should give you the result. Then you can plot the result, you can write the result. So if you follow that example, you should be able to start playing around with all of these things there and all of these arguments there, and you can see what happens. And if you find any problems, then just let me know. Then the second thing I want to draw your attention is to this climate data to use the package, right? So as I said, the package comes with example data, which is very low resolution, and you shouldn't be using that to run your analysis. Otherwise, your analysis is just going to come out very coarse, not going to make any sense. So there's functions both in the raster package and also in this analogs package to download WorldClim from the raster package and to download CCAFS climate from the analogs package. So there's functions for that. So in case of analogs, there's a function called getCMIP5, which has these arguments: variable, RCP, module, year, resolution, and path. So let's say that you want to download global future precipitation at monthly scale for RCP 4.5, year 2030, and a 10-minute spatial resolution. Then the function you have to run is like this. We'll go through a more detailed example next, right? I just want to make sure that you guys can navigate through this README file. And then in the raster package, there's a function called getData. So I didn't provide the example here because the raster package already provides that example. But getData is very similar to this function, getCMIP5. GetData, you specify WorldClim, you specify the resolution, you specify the path, and then it gives you the information. With these functions, you can get all of the different resolutions from either WorldClim or the CMIP5 datasets, right? And if you want to get the 30 arc second dataset, then you have to specify resolution to be 0.5. In that case, you cannot get the global data from this function. You will have to get just one tile. So you have to specify a coordinate of anywhere in the anywhere in the sort of geographic area that you're interested, and these will download the tile corresponding to that, to where that point is. This will become clearer once you start playing around with it, of course. So anyway, let's just go to the example. Hopefully that's going to clarify. So for those of you that have been able to install it, you can just go to the R console and type this. So just load the raster and analogs package, right? And load also this map tools package, which is then going to allow you to load this data world simple. And then this other piece of code here is just specifying your working directory. Don't type exactly what I typed here because you may have something, your configuration might be slightly different, or just leave it as it is, but then take into account that this the line after that is going to create a folder in your home directory, which is called like that. So if you don't want to keep it there for the long term, you may have to remove it, right? So I'm just going to run this for now. And that's it. So then I'm just going to download the working data, precipitation and temperature, right? So I just type the WC precipitation, is just the name of the variable, get data. And then I just say WorldClim, resolution equal let's say 5. Well, let's say 10, probably quicker. And path equal WD, variable equal prec, and then path equal WD. Right, then I'm going to I also want to download the temperature data. So I do the same. And then I just do it like this. So this is just going to run those things. Okay, so in my machine it's finished. I hope in yours it also has finished. So we can just check that everything is okay. WC prec, let's plot, right?
Global download?
Yeah, this is downloading the global data. Right? So this is, for example, just plotting the January temperature. Thanks. And then if I wanted to plot everything, then I can do it like that. Right? So let's just leave it January. So now we have the working data there. The next step would be okay. The next step would be to download the CIMI5 data. Let's see, C5 precept get CIMI5, right? So we need to provide the variable is the precept. We need to provide the RCP. Let's say 8.5. We provide the model. So the model is a numeric value, and this is something that is important. So there's a table called CIMI5 table in the analogs package. It's provided as part of the package data. So if you just open it like this, you will see there is a data frame that contains all of the models, right? It's a list of the models and all of the RCPs. For this table is basically a reference that gives you the model availability for the different RCPs, right? So you can use that to identify which is the model ID that you want for the RCP that you want. In this case, my choice would be 1, would be model ID 1, which is available for all RCPs. But in any case, I just want to download one model, one RCP. Then year is equal to 2050. Then resolution is equal to 10 minutes. And then path is equal to WD, which is my working directory. So I want to do the same for temperature, right? And then I just run. All right, so now it's finished. I can plot this stuff. So, right, let's see. So if I want to plot, again, this CIMI5 data, just to double check that everything is okay, I can do that. I can plot the 12 months. I'm not going to do that right now. And then now the next thing that I need to do is there's one small thing, which is I need to double check the coordinate reference system. Yeah, so for example, this doesn't have. Yeah, so I'm just going to make sure that the reference system is the same in the 3 data sets. So I'm just going to do this. Oh, temp. Right. And now I can, because they don't have the same reference system, then the raster calculations will complain about that. So now I just create my object parameters, create parameters as we learned before. So now I do X. So let's see, you can choose your own location, but I'm going to choose Amsterdam maps. So I guess this is more or less where we are right now. this is the so I just copied the information. So as you know, in Google Maps, the X and Y are inverted. Then the variables, I just do preset temp weights I hope you are able to follow. If you're not, I just see the questions that you guys are asking. Yes, this would be awesome. Building a shiny framework for this package, I don't think it's too complicated, and it would be super good. So if you guys, anybody in the group wants to contribute to that, let me know. Yeah. So mdata ref equals list. So let's say the reference is the current climate, because in this case we want to understand which sites are similar in the future to Amsterdam's current climate. Prec, and then we'll see temp, right? Is it list? Yeah. List C5 prec, C5 temp, and then we just do these three things. And then let's say the out file that I wanted here in this WD, I want the file to be named, Amsterdam, and then I want to write the file. So this is just the create parameters object, right? So now this is complaining. Growing season is missing. Growing season, I want the whole year. Oh. Rotation is missing. All right. Okay, let's say rotation thing. Rotation is, you remember I just mentioned about the...
We can compare it to places on the southern hemisphere.
Yeah, when the seasonal distribution is not the same, right? Let me show again. So I showed this. Are you seeing the slides?
Okay.
Yeah. So when the seasonal, when the amount of rainfall or the precipitation or the temperature, the average temperature is more or less the same, but then you have completely opposites or somewhat different patterns, right? Like winter and summer, right? Northern versus southern hemisphere. Or when you have, for example, the wet season being around December in some places and then being around July in others, but the actual amounts are similar. Then it rotates everything so that it becomes mismatched, right?
In West Africa, we have high temperature. In East Africa, it's different, something like that.
Yeah.
It automatically does the rotation for different areas.
Yeah. Yeah, exactly. So then, okay, then this is not complaining anymore. And then I can just calculate the result. Let's call it X, and calc similarity. And then I just have to provide this parameters argument, and this should work. So now it's still computing in this machine that I'm using. All right, now it's finished. So I can plot this result, X, so now I can just plot it, and you can see the result there. Let me try to zoom. So you can see what the similar places to in the future would be to Amsterdam's current climate, annual current climate, right? We could do the calculation for the winter if we wanted to. So let's say, okay, let me just leave this alone. Let's say that we wanted to calculate it for the winter. So the winter would be 12 until month 2. And then we just let's call it X2. Then now it's running. So, and as I said, you can, because we chose to write the files. So this is a Linux system. So I'm just going to check the files here, demo analogues. You can see the files there. The Sim 5 stuff, which I downloaded, the WorldClim 10 minutes stuff that I downloaded, and the output Amsterdam stuff. I forgot to change the name here, so this is going to get overwritten, but it doesn't matter. So now we can plot it again. X2. And then, yeah. So now this is the result just for the winter months, right? So you can see there's a difference in those X and X2. Let's just get rid of this. Yeah. So you can see there's a difference. The left one is the whole year. The right one is the winter months, right? So similarity seems to be, winter similarity seems to be shifting towards Germany, whereas whole year similarity is shifting towards, is showing that the climates are shifting towards Norway, towards Scandinavia, at least the South Scandinavia. So that means Scandinavia is warming, therefore in the future is becoming similar to what Amsterdam is currently. Yeah, so that's the examples that I had, and as you can see, you can modify any of these parameters and just try stuff as you wish, right? You can change these variables here. You can use the bioclim variables. You can use soil variables. Of course, the nice thing about using the monthly data is that you can have a workflow like the one we just had here, where we went all the way from having nothing to the code downloading the data from WorldClim, downloading the data from the CCAFS climate, calculating everything we needed, and yeah, and that makes things a lot easier. So it would be nice to have those kinds of functions for the soil data as well, so we can just download, stick it in there, and run the analysis. But that's it. That's what I had. If there are any questions or you want me to go back to any particular step, just let me know.
If I have to cut, a section, not global, like you know, Africa or some countries, how do you? Is it in the data download that you have to cut?
Yeah, so in this case, what you need to do is you need to download, you need to get a shapefile or an extent,
Okay.
right, that defines your study area, and then you use that to crop the climate data, right? So let's say that, for example, let's say that, for example, let's say that, for example, I'm going to create an extent for Africa. Let's say minus what? Minus 15 to what? 50 minus 50 to 30, 20, right? So I create an extent like I just did there, and then I just crop the working data. So working preset 1, I'm gonna call it, or let's call it Africa. I'm not 100% sure this is gonna come out correct because the extent I'm not fully sure, but let's try. So this is the command that will get it done in the raster package, crop, and then you can just plot WC prec Africa 1. Let's see, right? So this is more or less the extent of Africa, but we can correct it a little bit. So minus 40, I guess, would be better, and probably plus 30, right? Yeah. So once you crop the data, like I just did there, you can then run the analysis using this modified data, right? So instead of putting there WC prec and WC temp, then you would do it with the WC prec Africa, right? And WC temp Africa. So you have to do it for all of them.
Yeah.
Yeah.
In this set parameters, it's possible to send like a list of points, or just need to be 1 point?
1 point. If you want to do it for a list of points, you need to loop, do an apply, something like that. Yeah. Yeah. If the question was if you can provide a list of points instead of just 1 point. If you can do the analysis for several points at the same time. My answer is no. You can, but you have to just do the loop yourself, right? No. Yeah. It would just doing it over a polygon is just degrading the climate data essentially. which is fine. You can do that, but you know, it's yeah, it's better to do it at the highest resolution possible.
CIMIT has been using this for as long as it has existed. It has always been very, very useful tool. We started using it when it came out from CCAFS in R. And then there was a web tool also, which I think somebody in the questions also mentioned.
Yeah.
Which was an easy way to do it quickly. Like Julian said, sometimes you want to know how representative is that the trial site. And I remember 6 or 7 years ago, we had a student as an intern, and she ran all of the CIMIT wheat nursery trials, which are like 700. She ran that automated, like he was saying, in a loop. Very useful, and I'm very happy. I've struggled the last 2 years to get a running version from the old ones. So I'm very happy that CCAFS Biodiversity have made the investment to get an updated version with new data, and you can refresh the data. Alabi, you could also build your own data. If you have ensembles already made with CCAFS data, then you can import that one into R. If you have a TIFF or raster ASCII file from an ensemble, then you could use that one for the future climate, not just one model. So I'm very happy. Thanks.
Yeah.
And you answered a lot of questions today that I have.
Yeah, so the...
You have up to 12 or maybe 14, 15 layers of I think I had it for 5 minutes, and 12 goes to 16, 14 or something like that.
Yeah, you can add many, but you have to bear in mind that sometimes some of these properties might have some spatial some correlation between them. So it's good to select something to select a set of variables that is really representing what are the drivers of performance for the technology or the system that you're looking at. But yeah, there's no particular limitation on the number of variables. You just have to run an analysis for each variable, essentially. The analysis that Kai was talking about is I'm showing in this slide. I'm just projecting it. And this is what you see, the brown spots there are the international nursery locations for the wheat breeding program. And what you see in in colors, either green, yellow, or blue, is essentially the wheat areas classified into different similarity categories. You can see that in general, of course, the wheat locations are quite a few, but they cover fairly well the entire, they represent fairly well the entire wheat growing area. You see that there's a lot of areas in blue, and there's a lot of areas also in green, which is moderate representativity. There's a moderate similarity, and there's only very small pockets here, like in South Sudan, where wheat growing is maybe not so significant, that have sort of low similarity. So this is based only monthly temperature and precipitation, right? But it already gives you a sense, you know, this set of locations that CIMIT is using for testing varieties. Are they covering well the range of ecologies where people are growing wheat, right? This is the question that we wanted to answer there. And you can add to the analysis soils and then see what happens. There's a question by Andy about the growing season, right? So let's go back. So basically the growing season, I should have said, I'm sorry, the first number is the start, and the second number is the end, is the month number. So winter is effectively December, January, February, which is why I chose 12 to 2, right? And yeah, so it's generally just those two parameters.
The next part of my question is I get that because you can weight it so that you've got rainfall and temperature, and you can decide which of those two variables is more important. And then you can choose a subset for 12 months to say, I want to look at this time period. But I was also thinking, within a growing season, there are certain months which are critical. I need rainfall in this month, and yeah, the rainfall in the subsequent months can change, but it's not so important as this month. So that month actually has a lot of weight. You want to match something like this. This month is actually critical. So I'm wondering, can you also think of a way to have the weighting by month?
Yeah, it's clearly not included there. It's a good idea. It's a very good point. At this moment, the way you would do it is you would calculate separately and then just aggregate the
And do your own
result.
weighting afterwards.
Yeah.
Fine.
Yeah. But it's a good point. Yeah, I mean, often, for example, you want to have a consideration of the entire growing season, but then the grain filling is the most critical, so you want to give extra weight to that. Yeah. All right.
Generally, equally within temperature and rainfall, is it good to do that?
It depends what your interest is, right? If your interest is if for the performance of the system or practice you're looking at, you find that both are relevant, then you probably should be weighting both equally. If for the performance of the system or practice in question, one is more important than others, so for example, you're thinking about West Africa around Sahel, probably precipitation is going to play a bigger role in many processes. So I would say, you can give, I don't know, 70-80% of the weight to precipitation, and then 20%. We can run an analysis for the Sahel if that's in these last few minutes that we have. My computer has become increasingly slow with this big marker thing. Yeah.
So yeah, Julian, we have about 2 minutes left. So I don't know if you have any final remark you want to share with the audience today.
Well, no, I mean, just thanks for listening, and as you may be aware, there's a web page, but this web page that we have is not active. So you should engage with analogues through the R package, basically. And if you have any questions, if something is not working, just email me directly, basically. At this point, it remains a challenge to do the package maintenance, but it is not that hard because it doesn't have that many functions. It's actually quite a relatively simple structure. So for now, I'm maintaining it, but I hope somebody can take over at some point. But anyway, that's and no, I mean, and the ideas of having it as a shiny interface are definitely good and welcome. And if you guys, anybody from the group wants to contribute to that, just let me know.
Yes, exactly. So I mean, if there are enough interest, maybe that's something we can definitely discuss. And Julian, did you want to talk just briefly about CMIP6 data that may become available soon? And would that be also part of this tool?
But now we have 1 minute, so I wonder what we should do. Huh?
Or maybe instead of presenting it, maybe you can just mention just quickly.
Yeah, because I do have a few slides about it, basically.
Oh, you already have slides.
I do, but they're going to take more than 30 seconds. 18 seconds now. So is it possible to extend? I guess is my question. Yahoo? Can you extend the time in any way? Oh, too late.
You're the last session for today, I think. So go ahead, please.